Marine environments exert extreme physical forces on the vessels that cross them. Regulating their environmental impact requires a system accounting for those exact physical realities. In 2023, the International Maritime Organization enacted a new set of regulations to force international shipping to decarbonize. Historically, a ship's compliance was determined before it ever touched the water, through static design checks. The updated MARPOL Annex 6 framework eliminates that approach, replacing one-time design approval with a continuous operational grading system. The first component of this framework is the Energy Efficiency Existing Ship Index, or EEXI. This technical assessment calculates a ship's theoretical energy performance based strictly on its physical design and specifications. The second component is the Ship Energy Efficiency Management Plan, Part 3. This is a dynamic, verified document that details exactly how a vessel will achieve its required emissions targets over a rolling 3-year cycle. The final component is the Carbon Intensity Indicator, or CII. This metric captures reality. It measures the actual carbon emissions generated per ton of cargo transported per nautical mile. Together, the EEXI, CMEP, and CII form an interlocking triad. A ship's design sets its theoretical limit, its management plan outlines the strategy, and the operational indicator measures actual performance. This structure locks maritime operators into a mandatory cycle of continuous technical improvement. To see how this framework is applied in practice, we evaluate a standard 60,000 deadweight ton bulk carrier operating on international routes. Carbon intensity evaluates a ship's environmental cost against the tangible benefit it provides to society. It measures the mass of carbon emitted to move a specific mass of cargo over a specific distance. Determining regulatory compliance requires 3 distinct mathematical steps: establishing the reference CII, calculating the required CII, and measuring the attained CII. The relationship between those numbers determines the vessel's grade on a 5-tier system, ranging from an A for major superior performance down to an E for inferior performance. The regulations carry strict enforcement mechanisms. If a vessel rates a D for 3 consecutive years or drops to an E for a single year, the operator is legally required to submit a corrective action plan to its flag state or a recognized organization. A ship cannot continue trading internationally with meeting these standards. The calculation of carbon intensity is a direct mathematical derivation of a vessel's legal viability. The first step is establishing the reference CII. This is a fixed baseline limit derived from 2019 data, determined strictly by a vessel's type and deadweight capacity. This dynamic ledger displays the baseline equation for a bulk carrier. The reference CII equals a defined constant A multiplied by the vessel's capacity raised to the power of -c. For a bulk carrier, the constant A is set at 4,745 and C is 0.622. We input those alongside our vessel's capacity of 60,000 deadweight tons. Resolving the math gives us a final reference CII value of 5.061. That final number represents the absolute starting line. The physics of the hull and the initial design of the vessel establish the baseline limit, proving that no ship begins with a blank slate. To force industry-wide decarbonization, the IMO applies a reduction factor known as Z. This graph illustrates the trajectory of Z, a mandatory emission reduction percentage that systematically tightens year over year. For the 2023 regulatory year, the mandated reduction factor is set at 5%. This dictates the required CII. We calculate this by multiplying the reference CII by the remainder of the reduction factor. We take our baseline of 5.061 and multiply it by 0.95. The result is 4.808. That 4.808 is the required CII. It acts as an absolute regulatory ceiling. To remain compliant, the vessel's actual emissions must stay beneath this number for the year 2023. Because the Z factor increases annually, that ceiling is a constantly shrinking target. A ship's successful compliance in one year guarantees absolutely nothing about its compliance the next. The final variable is the attained CII. This is the measurement of the vessel's real-world fuel consumption and voyage data over a full calendar year. Let's apply our operational parameters. Over a 12-month period, our bulk carrier transported 60,000 tons of cargo across a distance of 12,000 nautical miles. During those operations, the vessel burned enough fuel to release exactly 3,219 tons of carbon dioxide. This equation shows how we find the attained CII, grams of CO2 divided by the product of deadweight and distance. Factoring in our totals, 3,219 tons of CO2 converted to grams, divided by 60,000 tons, multiplied by 12,000 miles, outputs an attained CII of 4.471. The vessel's final regulatory grade is derived from the ratio of its attained CII to its required CII. Dividing our attained 4.471 by our required ceiling of 4.808 yields a ratio of 0.93. To find the grade, we map this ratio against the IMO rating boundary tables for bulk carriers. The 0.93 value falls precisely between boundary D1 at 0.86 and D2 at 0.94. This places the vessel firmly within grade B, representing minor superior performance. The raw data of fuel logs and distance tables is translated directly into an unarguable legal grade. The mathematics completely strip subjectivity from environmental enforcement. To understand the pressure this system exerts, consider a scenario where the shipowner makes zero technical or operational improvements. This simulation holds the vessel's attained CII static at 4.471 from 2023 through 2026. As the Z factor increases each year, the required CII ceiling is driven steadily downward. Because the vessel's performance remains flat while the required denominator shrinks, the performance ratio mathematically swells. By 2026, the exact same fuel consumption and voyage data that earned a grade B in 2023 will push the vessel into grade C and finally breach the threshold for grade D. Hitting that grade D cliff triggers the regulatory penalty. If the vessel remains there for 3 years, it loses its certification to operate. Under the Dynamic Carbon Intensity Indicator framework, maintaining a static level of performance is mathematically identical to failing. Compliance requires continuous carbon reduction. Preventing that mathematical degradation falls to the personnel managing the vessel's systems. The crew and operators must implement rigorous countermeasures. On the engineering side, retrofitting a vessel with shaft generator air lubrication reduces frictional losses, yielding up to a 10% reduction in greenhouse gas emissions. Pairing that air lubrication with an optimized gate rudder system can push total emission reductions up to 13%. On the operational side, aggressively managing vessel speed acts as a powerful lever. Reducing transit speed by 20% can slash emitted CO2 by up to 50%. Every one of these interventions, from hull modifications to throttle limits, must be rigidly documented, tracked, and verified through the vessel's SEAMP Part 3. The ultimate objective of all these measures is a highly optimized ship, operating with maximum efficiency across the modern global ocean. The IMO 2023 framework ends the era of static compliance. Maritime operators are now bound to continuous life cycle optimization, where the engineering efficiency of the hull and engine is directly synonymous with the legal viability of the ship.